All right. So in 1 week, on Thursday the 25th, that's when your next exam is going to be. And isn't it already kind of crazy to think that we're 2 weeks away from the end of the second 6 weeks? It's going to start going fast. I mean, we're going to be out for Thanksgiving and Christmas very soon, but we want to wrap this up first. So the test is next week. In fact, this quiz is probably a really good indication of what to expect as far as the sets go. You'll have some more truth tables on there. Implication will be on there, things like that. And I'm thinking tomorrow, even if we're not able to finish today and we may only have a little left, I'm thinking for tomorrow we'll end the week. I'll just go ahead and give you the homework assignment. We can probably work a problem together, and then I'll give you the rest of the period to go ahead and work on that, and then you go your 3-day weekend. Peyton. Okay. Yeah, just remind me at the end and I'll give it to you. I've already got that printed up. Okay, good. Well, yesterday we started talking about implication, and we have this arrow as our notation. And the thing to remember is it doesn't suggest or mean causation. It's just that one implies the other. Okay, usually we have these if-then statements. And now we're going to go ahead and go a little further and say that our propositions, the first one's what we call the antecedent, and Q is called the consequent. Okay. But the behavior for implication was a little unusual. It did mimic proper subsets when we were talking about our intro to sets. But as far as the truth table goes, what was the only one we had to worry about? Only if it was true false. Okay. Only this situation right here. If we're saying P implies Q, first true, then false is going to give me a false. All other variations, we're going to go ahead and give me a truth. Right, Caitlin? Right. All right. Okay. And then I kind of walked you through a couple scenarios to help you kind of see the logic of that. Then we did an example. Now we started talking about the converse, inverse, and contrapositive. The converse is to what?
It's the opposite.
Is the opposite? You mean like the negation? There you go. So you just take the antecedent and the consequent, you go ahead and flip them. So if we're normally saying P implies Q, then Q implies P. Now the inverse would be to keep them the same order, but negate them. Yes. Okay, not P implies not Q. And then the contrapositive is to do both, to switch the antecedent and the consequent and negate both of them. Okay. And then we started talking about equivalence, where we have the double arrow. Now this was our if and only if statement. So we went ahead and added a couple of columns here in order to help understand the behavior. We did the implication, P implies Q, Q implies P. So when we're looking at the equivalence here, what was happening? How did we know we were going to get a true statement? Eli?
They both had to be, both P and Q had to be true or false to their true statement.
Yes. Okay, well we have here what I got highlighted, P implies Q is true and Q implies P is true. If they're both true, then they're equivalent to each other. And if you take a look in the first two columns we created for the implication, see we've got one false, so the equivalence was false. Okay, one false here, same thing. Okay. Oh, Libby, were you the pass man?
Oh, it's just towards the end.
Oh, did it? Okay. Okay. All I saw was a pass. Okay. All right. And Spencer, I absolutely apologize to you. I meant to have this copied. I have the notes right now. You can take a photo of it with your phone if you'd like to.
Yeah.
Okay. Let me go ahead and get that for you. I absolutely meant to have that copied, and it just slipped my mind, like a lot of things do nowadays. The ravages of age. This is where you guys were supposed to say, Mr. Yes, well, you're not old. You're not old. Oh, thank you. Thank you. Do we need to turn on the light, or are you going to be able to see that?
No, I can see it.
Okay. I don't like to think of myself as old. I like to think of myself as unyoung. There you go. How old do you think I am?
So you're an onion?
Unyoung. Not onion. But I will say, like an onion, there are many layers to me. Okay. So, Kiana, how old do you think I am?
Probably like 38.
Oh, bless your heart. I'll be 42 in January.
That's
Really? It's nice. I'm looking forward to that year because it's going to be the answer to life, the universe, and everything.
So you graduated in 94?
I graduated in 95. 95. Okay, there we go. All right, but if anybody else is interested, I do have this. That was a proof, and like we said yesterday, IB is not going to have you working on a proof. Now, we talked about a tautology. That's if the statement you get is nothing but what?
True.
Nothing but truths. Okay, that is a tautology. That is an absolutely true statement. If we get nothing but falses, that's what we call a contradiction. Or even if it's just one false, we could say it's a contradiction because it's not a valid argument. Okay, and this is where we got to yesterday. So we don't have a whole lot left. So let's go ahead and take a look here. We want to go ahead and show that the union of not P and Q implies R. So we're talking about implication. So just a little bit of throwback to the previous lesson. Does it make sense why we have 8 rows?
Yes.
How do we determine the number of rows that we're going to need for our truth table? Okay. It's 2 raised to the number of propositions. You always use base 2. So here we have 3 propositions. 2 cubed is 8. Now, for these right here, you're always going to start half and half. Like for the first proposition, I'm going to go true, 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 and then false, 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 false. And then I'm going to start breaking it down. Half of that as we go through. So true, true, false, false, true, true, false, false. And then again, we're going to take half of that. So now this is just going to alternate all the way down. True, false, true, false, true, false, true, false. So that with these 3 events all happening at the same time, or whatever it is that we're trying to say, you have every possible outcome. From the fact that all 3 are true, all the way down to they're all false. Yes, Libby?
How do you know what's a Q and R?
Well, in this case, we don't. In just a second, I'm going to provide you a few more because I didn't really have a great answer to Michelle's question the other day. What does the truth table have to do with the statements we're working at? And now that we're talking about tautologies and contradictions, I can actually show you that with the next example.
Yeah, my question is, are you just kind of like picking numbers or are you pulling them from something?
Am I picking numbers?
Okay.
Are you talking about the truths and the falses?
Yeah.
Oh, no, that's just the pattern that you always use. In fact, if you go back and take a look at when we only had 2 propositions, so we only had 4 rows, okay, you'll notice they're always going to start like that. So you take half of the number of rows you have, so it's true, true, false, false, and then it alternated there. Okay. The idea being that we want to go ahead and get every possible outcome that we can. Hey, Michelle.
And for example, the test, it's like an ask us to fill in a break that we already done for.
Liz?
Yeah.
Depends on the test. Now, all the problems I've seen have already had at least that first section filled in, but they're changing the test every year. In fact, I'm going to another training this summer because they're going to revamp IB again. They're going to change some of the curriculum. So, I would say more than likely, I would be willing to bet that your first 3 columns, or at least the first 2, would be filled in, and it's the other ones that you would be responsible for. Okay, but if not, we have the pattern. Okay. Okay, well, let's go ahead and look at that 4th column. What's that sideways L?
Opposite.
Okay, opposite. Okay, not P, the negation. So I just want to take everything in the first one and negate it. So every truth becomes a false, and then every false becomes a truth. Okay. And then now I want to go ahead and take not P or Q. All right, so let me go ahead and connect these right here. Now, this is the inclusive or exclusive or, as we were talking about at the beginning. This is the inclusive. So this means we'll get a truth if at least one is true. One or the other or both. So what about true, false? True. True, false is true. False, false? False. Another false, false. Then we have a true, true, so that one's still true. Now, if it was exclusive, if we had the bar, that one would have been false. The exclusive says not both at the same time. Okay. And then it looks like we have true, true, false, true, and another false, true. So it looks like only the 3rd and the 4th rows in that column are going to be false. Okay. Now, we got this last one to fill in, and this is with the implication. Would you like to try this one on your own?
Sure.
Okay. What do you think? 30 seconds? 45?
45.
45. Okay, so 45 seconds. Let's see if we can get that last column filled in. And remember, order is very important. So I'm looking from this quantity to R. You're going in this direction. And there was just one scenario that you needed to be careful about. Okay, that's 30 seconds. Okay, so that is 45 seconds. Now, like I said, the order is very, very important because the quantity is implying proposition R. We have to go in this direction. Now, with implication, what was the only one we needed to look out for?
True, false.
Only true, false. And do I have any of those?
Yes.
Okay, the second row, I've got a true, false, so that's a false. If I can write a false. Okay, anything else? Okay, third to last, here's another true, false, so that's a false. And the very last one itself, true, false, so this is a false as well. The rest of them should be trues. How'd we do on that? Okay. So how would you classify this? Would it be a tautology or a contradiction? I'd go ahead and say it's a contradiction. Okay, now you don't have to get all falses, but it just says that it's not a legitimate statement. Okay. Whatever those propositions are referring to. Okay, now this will go back to help Michelle with her question the other day, the one that I kind of really couldn't answer until we actually really talked about them. Okay, so it says testing the validity of simple arguments using truth tables. Okay, use a truth table to show that the following argument is always true. Okay, so if we are correct, we should be getting a tautology out of this. That means the final column should be nothing but truths. Hello.
Mr. West, do you mind if we
Do you
do
mind
a
if
sales
we do
pitch
a little
for...
sales thing?
Sure, come on in. Okay, here are some of my students, guys. They want to talk to you for a second.
Hey guys, so we're selling tickets to this performance of Mamma Mia. If anybody wants to buy, you're gonna miss second, third, and fourth period for $5.
Yeah. Buddy?
Spencer's in it.
Fantastic.
I'm in it.
Wait,
Hey.
Spencer's in it?
Yeah.
Emily's in
What?
it. Didn't see Emily's.
And you also do get to see Noah without his shirt.
And I did take off my shirt.
You get to see who?
Noah.
Guys,
No,
Noah.
Oh, okay. So,
We're not selling the other ones.
this is just for the school.
This is just for tomorrow.
no takers. For
And-
tomorrow, $5. You get to miss, what, second, third, fourth?
You would also buy a ticket
And
now.
it's excused.
And you wouldn't miss 6, so that's the good news.
It is to see West.
You could also sell your tickets off to people for higher prices.
Oh,
So,
you can learn how to be a scalper in high school. Kiana, you want to buy one? Oh,
Nobody.
no takers?
wow.
Okay.
All right.
Okay.
I see how it is.
Bye guys.
Thank you, Mr. West.
All right, very welcome. Okay. All right. Yeah, that's the greatest news. It doesn't take you away from your math class.
No, she said how dare they interrupt our math.
Oh, well, you know, it's Spencer. What did you say? Spencer's in it. Emily's in it. Is there anybody else in here who's in it? Okay. Hey, Caitlin? Okay, nice. Do any of you sing in it? Like solos?
Yeah, me and Emily are Sam and Donna.
Oh, nice. Very cool.
Big kid.
Okay. Now, it's only an hour and a half, right? Oh, really? It's 2 hours? Okay. Okay.
If I go to the
Okay, all right. All right, well, let's at least go ahead and get this one started so that tomorrow we come in, we can finish up the last one, and I can get you working on your assignment. So we've got these statements here. If Fuzzy is a bear, then Fuzzy is a mammal. Okay, there's my implication statement. Fuzzy is a bear, therefore Fuzzy is a mammal. So look at my propositions, okay? We've got that Fuzzy is a bear, and the consequent, Fuzzy is a mammal. Okay, the entire argument can be written symbolically like this. See, because we have the implication, we have the if-then statement. So if P, then Q, But for this implication to be true, we're given this. Okay, so if this implication is stated and Fuzzy is indeed a bear, therefore, then I can say Fuzzy is a mammal. Okay, and see what we've done here is just broken down those propositions, the antecedent and the consequent, into your symbols. And you're going to get the opportunity to do that probably tomorrow, okay, because I don't think we're going to have enough time today. All right. So let's try this. And again, look at the pattern here. We've only got 4 rows, but you see how it went halfway? True, true, false, false, and then true, false, true, false. Okay. So I want the implication. Okay, Alejandra, what is the only scenario we need to be careful of? The true, false. So the true, false right here would be a false. The rest of them are going to be true. Okay, so now I want the implication and P. So what are we doing here? They both have to be true in order to have that true outcome. So let's see here. True, true is true. Okay, and the rest would be false, yes. Okay. And then I'm guessing that this one was put here just so you could see the order a little better. You know, unlike the previous example, how we went from that quantity, we had to work backwards. So I'm just going to go ahead and put Q, the true, false, true, false. Okay. So let's see here. With the implication, true, true would be true, false, false. What about a false, true? True. And a false, false would be true. So this is a tautology. This is a logical, valid statement. If there was any false, we can't say that. We have to say it's not legitimate. Okay? That's the whole idea. All right. Well, 204. And I think, is this the very last one, or was there one after it? No, that was it. Okay. So, I don't know. Do we want to rush, or we could use this as the review problem tomorrow? I'm kind of thinking that might be better. You want to do that? But, I mean, I will move forward if you want me to. Let's take a vote. How many people want to keep pushing forward? Okay, 1, 2. How many people want to go ahead and stop for the day? All right. Democracy rules, at least in this classroom. Okay. Thank you, folks.